Okay, folks, so let's start. And today we'll study another important topic, which is network layer, concepts of network layer and security, right? So if you understand in internet, primarily network layer and transport layer, with knowledge of data link layer, which is Ethernet primarily, then you have almost full understanding of internet, right? So this is the most important layer, because if somebody asks you what is internet, you say the internet is based on IP protocol. Okay, that's the correct answer. Okay, apart from IP layer, there can be any other layer. Today we have TCP, UDP, and other protocols. It could be any one of these on top of it, right? And new protocols keep coming in at high level. All we know is about TCP and UDP, but it could be anything. Similarly, below, the de facto standard has become Ethernet, but packets also go over PPP, or it can go over Sonnet or any other technology, link layer technology. Something that's common is IP. Okay, so remember this thing. All right, so after doing this course, don't do this mistake of getting into any honey pot. Okay, don't go to any malicious website and places where you can be fooled. All right, so listen to your spouse or your partner. All right, so these are the things that we'll cover today. Contents are just too many, and so I will be very fast. In case you don't understand anything, please let me know. Okay, so we'll repeat again and again the same concepts until it goes to your head. So in last class we studied about link layer, primarily Ethernet, and we also studied about VLAN. We also see what kind of attacks can happen, right, on Ethernet, right? Okay, but we didn't study about attacks on VLAN. We don't have time. Also, we have Wi-Fi is based on Ethernet, but we don't have time now. If time permits, at the end we will cover it, because this is another very important technology. Of course, Ethernet, but in wireless form, but it uses number of security protocols, right? Encryption protocol. Okay, so if time permits, at the end we will cover this as well. How do we secure LAN? Of course, one option is don't do anything. Assume all good people around, but that's not the option. Okay, so when you have a small router at home, that's a inside it is Ethernet switch, then most of the cheap switches don't come with security mechanisms. Okay, so sometimes you are happy buying cheap stuff, but obviously something that's cheap may not give you security mechanism that are there into switches. And second option is the smart switching and active monitoring. Okay, of course, I mean, we have seen the concept of VLAN as well, right? VLAN will reduce the scope of attack. It means that it divides the network into kind of subnetworks, uh, and the domain of broadcast is limited. Okay, all right. So now we have smart switches that will limit the broadcast domain, because the Ethernet by itself is based on broadcast technology. When it doesn't know where to go to, where the packets can be forwarded to, then it broadcasts the packet to everywhere. Okay, similarly, there are other protocols that are based on broadcast mechanism, like we have seen ARP, DSCP, etc. They all use broadcast domain, right? So if you limit the broadcast domain, it means that broadcast packets are going to less number of nodes. Okay, the probability of malicious node reduces. Okay, and high level switches can do a lot more. They can look at what's happening inside the switch. Okay, what kind of packets are coming, and then do a lot of good things around it, right? All right, so so there are filters, the Okay, so basic idea is to constrain the broadcast domain. It can be done in many ways. Okay, and secondly is that locking down the LAN. What does it mean? Locking down the LAN is very important practical security, right? So, so basically, it tries to reduce the chances that any attacker can attach to the switch and disrupt the switch. Okay, all right. So it must be having some. Now it has some intelligence that somebody totally unknown connects to a physical port. There's a probability that switch software can find it out. Okay, all right. Based on some information, right? It would have possibly got information about all MAC addresses of machines or laptops that are connected, and then something totally new happens which has been used in the past for hacking, then possibly it can find it out. Very, you can find cheapest routers for as less as that $50 nowadays. Okay, or even $10, something like 700-800 rupees. But expensive switches, enterprise switches cost about $1,000 plus, right? So if you buy Cisco switches, high-end Cisco switches, it will be expensive because it has a lot of security mechanism built into it. Okay, and then we have seen we can create various kind of subnets in that, guest wireless, employee wireless, production desktop, and so on. So it's done usually VLAN mechanism, which you studied in last class, right? All right. Okay. So that was about layer 2. Now let's study layer 3. Okay. All right. Internet design goals, we have already studied that, but let's repeat it. Internet, when people who were pioneers who actually thought of internet, they just did it as an experiment. Okay, they wanted machines to be connected over packet switching, right? So they designed it with a flexibility in mind, because that time link speeds were very low, right? 64 kbps or even lower than that, just about 40, 30, 35, 40 years back, right? Okay, dial in, most of the people converted analog technology into digital technology by dial-in methods and modems and so on. So it was very slow link. The whole idea was that somehow packets should go to other end. Okay, so it supported interconnection. It means that you can have networks of different kinds. Okay, different technologies. For example, it could be ATM, it could be DSL based, it could be Sonnet based. Then internet, there has got to be interface and there has got to be IP address, and then internet was created to interconnect these networks, right? So this is called interconnection technology. Is a failure resistant? It means that if packets are going from one node to another node, say for example this node to the node here, and the link fails, then packets can be rerouted. As simple as that. You are going from, say, IIT Mandi to Delhi, and you find that path towards Sundarnagar is not some is disrupted because of something. Then you take up some other path. All right. So similarly, IP packets take, these switches or routers will exchange information about failure, and then packets can be routed to other path, right? So this is failure resistance. Okay, it supports multiple types of service. It means that packet can carry almost anything, whatever you want, it can carry, right? It connects variety of networks. It provides management resources and should be very cost effective. Look at the beauty of internet, right? See, just about 30 years back, 20 years back, there was no voice or IP technology, right? Which is used now. You do WhatsApp call, or what we are doing right now is nothing but packets going over IP. So imagine, making a call to US from here would have And I paid as much as about 150 rupees a minute, okay, for international calls. Now the calls to anywhere in the world is free because packets are going, your voice is going, uh, is it voice is just converted in digital form, and that bits are going as a payload to IP, and IP is going on internet, right? So packets are reaching the other end, and your voice is reassembled back. Voice bits are assembled back, and you're able to listen to somebody who's speaking thousands of miles away. Okay, so it's cheap now. It's so very cheap. Okay, why is that? Because because internet is it's very simple and plain technology, right? And anything can go over payload of that. Okay, you need to just convert whatever, like document or movie or whatever, into digital bits, and other end should be interpreted back. Okay, low entry cost, it means that anybody can use it. Uh, and accountability of resources. So, okay, accountability is not that important point, but in general, I mean, all resources should be managed and used effectively. All right, but there is nothing like security. It's not designed for security. It's designed for connectivity. Is designed is with the thing that everyone is honest. Okay, so it's there is implicit trust, and so you can see all the protocols that are designed is based on implicit trust. Okay, and one thinking was that if you need security, you do security at the edge, like endpoints, like we are doing encryption, etc. It can be done only at the endpoint. Why create, why have security mechanism all throughout in the network? Oh, that was the idea, right? It worked beautifully. However, we can see there it causes a lot of security issues, and we are trying to fix it. But basic network, all the routers in between, etc., from your end to that, they do not have any security mechanism. Okay, all right. So now it's you who is connected to the end, and the party that's receiving it has to make sure that you take care of any security threat. Any question? No? Okay. Then we have seen that there is a layered architecture, right? Internet is based on layered architecture. So if we have a network, okay, like this, and there are various links here, types of links, then this link, okay, the IP packet goes over this link layer packet, right? So basically Ethernet, for example, if this is Ethernet, then it will go over Ethernet. And when it reaches to other end, this IP packet is removed from Ethernet, and then destination IP address seen, and this sent over to appropriate link. And if the link type is, for example, different, say Wi-Fi, then it's packed inside that same IP packet will go into this frame. All right, so this is a mechanism that we have studied in the last few classes. In maybe 2-3 classes we discussed same point. So HTTP packet goes inside TCP packet. TCP packet goes inside IP packet. Now this IP packet travels over various links and reaches to the other end as it is. Okay, so now this same packet will come to, if there are network like this that we have seen, then this packet as it is will come to other end. Now it will be put inside various link layer frames or link layer packets, depending on what kind of link one has. So for example, here it has put inside Ethernet frame. Now when you are putting inside Ethernet frame, then you will see that there is Ethernet destination address, source address, and destination address. Okay, this is all right. Okay, so for example, in a LAN, packet is received here, and it has got to go to gateway. Then the address here, the destination address like this one will be that of a gateway. All right, so that point we have discussed earlier. All right, but at the end, finally, when the packet reaches to the destination, for example, then this packet will be visible there as it is, right? In between, this outer layer will change. Our outer packet will change, right? All right. So now here it goes over wire. It means that all this is converted into digits for transformation. Now digits here, while digits that is transmitted is could be different. I mean, you can do some kind of coding, or voltage levels can change and so on and so forth, right? So that depends, or it can convert into light pulses. All that can happen, right? It goes over the wire or wireless. Just a minute. Okay, and then received here. You can see now, this from and to is different from the from and to that was here. Okay, because Ethernet or a link layer addresses change. Okay, but you can see that just a minute. You can see that IP address 1.3.4.5678 remains the same. Okay, like your mom is sending you laddus, then she will write your hostel address. That will get inside. When its courier guy takes it, it will just put inside a bigger packet, and then in that packet, from and to and from would be local courier guy's address to other end where it's sending, right? End of the link, end of the one route, one hop, and so on and so forth. And then again at that hop, its packet is removed, seen, that is your address, then again put inside another envelope, and so on. So this way, you can see IP address remains the same. All right, so we have discussed this point. All right, and then we have TCP port number, you can see, which we'll discuss in the next class. Port is nothing but is an interface point where data can go to a particular application. For example, see, a machine, your machine will have just one IP address, but that may be running multiple applications. When your laptop receives a packet from somewhere, it has to route to proper application, so it uses then we have ports for corresponding to different applications. Okay, all right. So we have this kind of communication which you studied earlier. Okay. So network layer is essentially layer 3 that we have already discussed. Okay. And what we do is that it's nothing but it defines two things. It does. It defines the format of IP packet, how IP packet will look like. That's first thing it does. And second thing that we are not discussing here, it also defines how packets will be routed. When we say routing, it means that different routers from your end up to you reach to the destination. Say for example, here, packet has to follow some path depending on the condition, local condition of the network. Then these routers exchange information about various things. How much is distance, for example, between this and this subnet. All this information is exchanged, and finally all routers come to some understanding. Okay, so there is a protocol for that, right? We have BGP, ISIS, and so on. There are multiple protocols for that, for this reason, right? So these routers know if it receives a packet with destination IP address, it knows which link to send it to. So that information it has because of exchange of information using these protocols. Any question up to this point?
No,
Okay,
sir.
Okay, can you ask Pradeep Meena to call me afterwards? I mean, he's trying to log into the class now after 20 minutes. Okay, all right. Let's go ahead. So we have seen that two subnets can be connected through routers. So here it's a LAN, right? This is another LAN. Okay, all right. This we have seen, and this diagram we have also seen, right? That link layer could be anything, but IP packet remains the same and traverses to the end, right? So this we have already seen, right? So packet must have at least three things, right? It should have source address, who's sending it, and where it is going to, destination address, and the data. And there are a lot of other information, of course, in the IP packet that we'll see, but these are the main that is required for transmission of a packet or any technology, communication technology. It has got to have these three things, right? Like even if you send a packet, your laddus that you receive, and then these three things are necessary, or PS or even postal services work on these three things: that what is the source, who's sending it, where is it going to, destination address, and all these things. Destination address has got to be unique for it, and what it contains. I mean, if you give contents are also important. You can't send bombs put inside a packet and give it to a postal office. They will not deliver it, right? Okay, all right. And there is also concept of fragmentation. Now let's assume that you have a very big machinery to transport from one station to another station, or one place to another place, and then you have trucks which are of a smaller size. Somewhere you have big trucks, somewhere you have smaller trucks, and these smaller trucks cannot carry such a big machinery. So what do you do then? So basically you deassemble parts of that machinery and send them in a separate trucks, and finally they go and you reassemble back. Similarly, some routers cannot handle large size IP packet because packets could be of 64K size. Okay, they cannot handle it. They are smaller switches, right? Then these packets are fragmented into smaller packet, and these smaller packet travel towards the end destination, and destination will reassemble that. Now obviously, when you are reassembling it, you need to know which is the first part, second part, and third part. So there is a sequence numbering, etc., etc., right, for reassembling. Now one important thing is that packets, the whole IP technology does not guarantee that a route will be followed. The different packets can follow up with different paths, right? But most of the time they follow the same path, because routers don't change understanding between them. But there is a possibility, if there is a congestion or some link failure has happened, then part of the file which is converted to a number of IP packets, few of them may take different paths. Okay, all right. So this is the format. Okay, so most important thing that we see here is source address with 32-bit. Of course, is IPv4 packet format. Then destination address, these are very important parts, and of course the data it carries, right? And then there are other fields that we'll see in the next diagram, right? So other fields are version number, whether IPv4, v6, what is the length of the header. Header is part that is overhead in some sense, right? So this part. Okay, and this is actual payload or actual data. Okay, type of service. Now I will skip this because there are diffserv and some other ones. Total number of bytes, length is total number of bytes in this one. Okay, then we have time to live. How long this packet should be alive. Suppose somehow it keeps on rotating in the network, okay, because of some reason, then some router should take it out of the network, right? So this defines time to live. Okay, and we have seen that any technology, whether Ethernet or whatever, it has to define what is inside that box or packet. What is the payload? Payload kind is so next layer can be given to right layer then. Okay, So like, I mean, even in normal case, when we give something to a post office, then we write what is inside. Okay. Similarly here. All right. So these are the, and then we have here corresponding to fragmentation and reassembly. Because if one large packet into split into multiple small packets, they should be reassembled back, right? So you should have number 1, 2, 3, 4, etc., etc. All this information comes here. Anyway, we are not going to discuss that because it will take few classes if you have to go through complete. But get the overall view, or just visualize it how it works, right? Okay, all right. So overhead is 20 bytes of TCP, 20 bytes of IP, and then actual content. So part of this is suppose the TCP, then part of overhead will be TCP, and then the actual contents. Okay, IP addresses are 32-bit in case of IPv4. Okay, IPv4. Okay, and we usually show is as 4 octets, 35.163.72.93. If it is 128-bit address in IPv6, then we show this as a 8. Okay, it's basically written as 8 groups of 2 hex bytes. Okay, all right, like this. Okay, now these are unique addresses in the sense that there can't be 2 devices in the world that has got IP address and that IP address is same. Okay, all right. Now otherwise routing cannot be done. Now can you manipulate this? What kind of tricks you can do? If there is a mallory, how mallory can manipulate all this? Now can you define your own IP address? Does it help? You can fake IP addresses, right? Nobody says no. All right. So this is a big problem, right? So we'll see that. So all the functions.
Excuse me, sir.
Yeah.
But public IP address is provided by the ISP, right?
Yeah.
How can we fake
Let
that?
ISP provide whatever it provides. But when who creates packet? Your machine is creating packet, right?
Yes.
Now who's writing addresses there? Your software is writing IP address, right? Source and
Okay.
destination IP address. You change your IP address. Who cares? Right? I mean, you send a letter to chief minister of the state. Whatever you write, and write your friend's address there or your enemy's address, or sender's address. Nobody can store. Same in IP. There is no validation. There is no authentication of source address, source IP address. Okay, all right. So these are the okay, all right. Coming back. Okay, so there is no guarantee in which order in which packets will come. Key function is routing. Okay, and each host must know the gateways, right? I mean, if you are inside a local area network, then you should know what are the gateway address, so you can send it to that. Because packets off from one gateway to another gateway, and so on so forth. There can be local network inside, and your Ethernet will take care of that, or whatever layer 2. Okay, fragmentation reassembly that we have seen, large size packet can be split into small size packet. And then there is something called error reporting. What happens? Let's assume this router fails. Then all other routers should know that something has failed and then can reroute, right? So there is something called ICMP messages or kind of error reporting messages sent back to sender. Okay, or other nodes, right? Suppose if the packet is dropped somehow, then there should be some mechanism to inform back the sender your packet is dropped. Then ICMP is used for that. And time to live, we have already seen what it is, right? Okay. So is the IP, as we have seen, is unreliable and bad suffer delivery. Packets may be lost, corrupted, and so on and so forth, right? Okay, so I'll just please go through it. Now, the problems which can be exploited, shortcomings which can be exploited are no authentication of source address, IP address. Now, it means that anybody can fake any IP address, right? So it's one of the very important or very critical weakness of IP layer. So if Alice received a packet from Bob, she cannot be very 100% sure that actually Bob has sent that. It could be Mallory who has created a packet and put in their Bob's IP address and sent it. Okay, and IP spoofing, basically using somebody else's IP address, is one of the common techniques for cyber attacks. So you'll see that. Other thing is that because of there is no authentication, then you can do man in the middle attack. And thirdly, is that anybody can send IP packet to anybody else. Internet doesn't say that, don't say packet to president of US. IP address of president's mobile phone or laptop, you can send it. Okay, is it good or bad? You have to decide. All right. So these are the flaws. Threats on internet. Image dropping, anybody can read the content if it's not, because everything is available in plain text. Whatever IP packet, whatever is going in the IP packet, whatever the bits are being said, it can be read. Spoofing, one can also pretend that somebody else, right? DDoS attack, okay, denial of service attack, we'll see how we can do that. You can modify the contents of this. Mallory can always modify contents of IP. Infect can put something malware here. Exfiltrate can take out the packets. Okay, traffic hijack, all the packets that are going from one source to another source can be hijacked. It happened once about, I think, 20 years back. I don't remember correctly, but Chinese hackers, and the claim of US is that actually Chinese government did that, is that they changed the routing protocols, like BGP, etc. And for few minutes, the whole world's traffic was going through China's routers. So what they have done, of course, is anybody's guess, but it's possible to hijack the complete traffic. Okay, so what we are going, there are a lot of attacks possible. We'll look at only few, that's IP level vulnerabilities and ICMP attacks. Okay. Of course, this point we have seen that network packets pass through untrusted hosts. How do you know that your packet is not going through China's routers? And they can always see it. Okay. So it's called sniffing. They can see what's happening. Okay. IP addresses are public. Your IP address is known. It should be known to everyone. The moment you send your packet, your IP address is known to receiver, right? So there's nothing like your address which is not visible to outside attackers, right? Everyone's IP address is visible somehow or other. Okay, so and this can be exploited. And okay, so basically anybody can spoof somebody else's IP address and send the packet. And then all the routing protocols are based on simple thing that is all trusted parties. All protocols that are designed, okay, in internet are based assumption that both ends are honest, because both ends are running a state machine. Okay, and that state machine is well designed by companies, so the assumption is that everything is okay. All right. Now note that there are a lot of protocols like R login, RSH is R host. These are old generation protocol, right? Now it's still being used for remote login, R login, right? If you're using it, then you're in trouble. Because only way authentication happen is based on IP address. So now if a packet comes from a specific IP address, my IP address for example, then I'm allowed to get into a server. Okay. Now if somebody, it means that now somebody can spoof my IP address, can use my IP address, then that packet, that person's packet is allowed to go in. And secondly, some features like fragmentation and reassembly can also be exploited. Okay. We'll not look into that, how this can be exploited. Let's look at some commonly used vulnerabilities, right? IP address spoofing we have already discussed. Anybody can forge anybody's source IP address. Okay. Yet how can then it can be misused? Of course, we have seen that some of the badly designed protocols, or those were designed 20, 30 years back and is still in use, like R login, etc. You know, if you use somebody else's IP address, then your packet can also go in if that person has authority to, get into a system or server. Okay. All right. So this is, of course, now first advice to people is that don't use these protocols at all. Okay. So let's look at wrong source address. Right. So what happens is that this IP address of machine is, this machine is 200.1.1, but it uses IP address of some other machine, this machine, which is 150.1.1.1. Okay, this machine, and destination is this one. Destination IP is corresponding to this one, 100.1.1. What happens? So now if send a message here, then response will go to this machine. Okay, this is, for example, this Trudy. Trudy just creates packet with somebody else's IP address. This machine keeps receiving packets and will, once the packets comes here, this machine has to receive it and process it. How can this be manipulated then, right? We'll have to see. Okay. Other thing is that source address is address of non-existing machine. So it will send it to somewhere. Okay, response. Okay. So this could also create problem. We'll have to see what kind of problems this can create, right? So countermeasures of this is ingress filtering, basically blocking the packets from outside the network with source address inside the network. Basically, okay, there is a gateway. Okay, it will see the packets that are coming in, IP packets are coming. Look at the IP address of that. Okay, source IP address. And with the source IP address, it has some doubt about source IP address because the source IP address may belong to some machine inside. Then the packet can be rejected. Similarly, we can go egress filtering when packets are going out and is using source address which corresponding to somewhere else, then it can be rejected. Okay. And of course, there are other layer, TCP, when we study TCP, we'll see how some of these things can be taken care of, right? Okay, all right. So these are the address level spoofing. There can be lot of problems. Okay, we are not discussing. Now you can create a scenario. How can you disrupt communication of any machine? Okay. Now, okay. So another protocol that is we have not discussed here is ICMP. Okay, these are supporting protocol. IP is the main protocol, and these are the supporting protocol like ICMP and IGMP. Okay, At layer 2, we have seen there ARP and RARP are the supporting protocols. Okay. So now ICMP, we know that it is used to inform the source that something wrong has happened. For example, you have sent a packet to destination node with certain port address. Okay, for example, you are doing HTTP, it goes to a certain port, and now that application is not working or not on, then the packet will be dropped, because the server is not able to send it to particular application. Then your machine should come to know that that application is not available. Okay, you would have seen that destination node is not available, right? So these kind of message that you receive, and I'm sure if you use internet you would have received it, then it is through ICMP. Okay, all right. So it's nothing but collection of error messages. All right. For example, destination host not reachable, reassembly of packet has failed, or TTL or time to leave has become 0. Another thing is that ICMP redirect message which tells host that you have better path available. So host doesn't know where to send it to, right? So let's assume that in a net there are 2 gateways instead of 1. Okay, and this is the source, your laptop. It will send it to one of the gateways. Okay, while the path is very, very long. Then the ICMP protocol, somewhere or other, some route will send you a message that okay, don't use this gateway but use some other gateway. Okay, that's called the ICMP redirect. And I'm sure you have used ping. You ping it to a node and see whether it's active or not, and we use this word, let's ping each other or something like that, right? And there is a protocol called trace route. So ICMP goes inside IP packet, because it, we can see that it sits on top of, it uses IP. Okay, so payload of IP becomes ICMP. So we create, whenever we want to send ICMP message, we create IP packet, and this IP address, if we're sending it to source node, then that destination address will be that of a source node. Like if I am sending something, some IP packet, and packet is dropped, then router in between will tell me that okay, your packet is dropped, then it will use my IP address as a destination IP address. Okay, all right. So obviously it will have 2 fields why it is dropped. Okay, so these 2 fields, type and code, are used just to tell back that what happened to packet. Okay, or some other information that it pass on to, right? So we'll see what are those. Of course, it's not kind of part of this course, but need to know. For example, if the type is 0 and code is 0, it means that echo reply, ping reply, you will get through that, right? When you ping to a node and node replies back, then it will come through 0 0. Okay, destination network not reachable, type 3, code 0, and so on and so forth. Right? TTL exploit is 11 0, and so on and so forth, right? So you will get all this. So you send an ICMP request, for example, ping request, which is nothing but converted into, in ICMP form is called echo request, and you will get, this will respond with ICMP reply. Okay, of course these are some of the types that we already seen. So you send echo request or ping request. Ping is of course converted by OS into echo request, and then it will send yes, I am alive. Okay, you can try this. Okay, all right. Then you can also get request for timestamp request, and receiver will respond with a timestamp reply. All right. Okay. Okay, please go through this. I will ask few questions based on ICMP. Okay, so you can see that ICMP, there is IPMP header and so on and so forth, right? You can see that there is one IP header and second IP header. So when I have sent an IP packet to, for example, to some end machine, and in between router will receive this and will not able to process it. Okay, so what it will do is it will use my IP address and create another IP address with my IP address, Ravi's IP address, and then it will tell why using some code, etc. Okay, and then put part of my packet here, such that I am sure that actually it corresponds to me. Okay, all right. So you can see again same thing which we discussed earlier. Okay, so I suppose we make a request, HTTP request, and then port is not available. So it's a service on port 80. It's not available, then we'll receive ICMP message back that port is unreachable. All right. Now let's think what kind of attacks we can do. Note that there is no authentication done on ICMP message. What does it mean? Anybody can create these ICMP messages, right? Can we exploit it? Yes, we can exploit it, right? We can use redirection, fragmentation. We can create a part fragmentation also. Fragmentation reassembly. You create a packet and post that is a part of the overall packet, and then at the time of reassembly there can be problem, right? Destination unreachable kind of message can be created, and so on, right? So if you want to see more stuff, you can go to this website and get. All right, so first is that ICMP redirect message, right? We have seen in a net subnet there can be multiple gateways through which your packet can go to outside world. Okay, now, and we have also seen that somebody else, some node can tell don't use A gateway but use B gateway. Okay, so this is a good gateway, and attacker can pose as a gateway then. Okay, and attacker will generate a message, ICMP message. Okay, it creates a ICMP message. Okay, and say that okay, better gateway is this gateway, attacker's gateway. Okay, so now host A will send all the packets to attacker's gateway or the gateway that attacker controls, and then this attacker will internally read the message, modify message, and can send it to actual gateway, good gateway. Okay, so as a result it can do MITP, man in the middle attack, MITM. Okay, all right. So this one attack. Second attack is called reflector attack. Okay, it's also called denial of service attack. This attacker, say Trudy or this Alice victim, right? How can it then do something? Okay, now here it will generate ICMP echo request or ping request, right? It will just do ping, it will do ping. It means that now it's a pinging to some machine here. Okay, and then ping, it will respond back. That machine will respond back with a ping reply or echo reply, right? Now in this echo message, it will send use source address of Alice instead of its own IP address, right? So now what will happen as a result of this? Okay, it creates packets with victim's IP address, right? Okay, so packet will go here. Now it will use, instead of unicast address, it will use multicast address. So this packet, ICMP packet or ping packet or echo packet will go to multiple machines, and it will have source address is not that of attacker but Alice's source address, right? So all these guys will respond now to the source, and this machine will get millions of packets, and this is called denied. Also, this machine has to then process that and then cannot do anything, and then we can go distributed way in this way, right? So now we can think of like your laptop, your mobile camera, mobile phone, and all millions of machines have a bot Okay, an attacker will will create a hierarchy of masters, and each master will control millions of bots. Okay, and attacker will say now we'll have to DDoS attack all these and will say what is the victim's IP address. Okay, this is a victim machine, right? Some corporate. This IP address. So all these bots or demons will use this IP address as a source address, and then send or broadcast this ping messages with source address of that of victim, and this victim machines will be bombarded with millions of ping messages, right? Ping replies. All right. Okay. All right. So this another attack is through attacker sends a ping request, ping packet which is larger than 65, the maximum size that's allowed. Okay. So now this large ping packet is fragmented to small packets, and the destination victim machine will reassemble them, and then in order to reassemble them, it may not have enough buffer. It may not have, right? And it can crash reassembling it, right? All right. Okay. So if you want to see what are DDoS tools, you can go to these places, sites, and get these tools, right? And then, however, remember that it's a criminal activity if you want to use these tools, right? In controlled environment, if you want to create number of bots or VMs and use this experiment, you can always do that. All right. So what do you studied today? IP layer is the most basic layer of the internet. Now note that there's no authentication, no security. Anybody can spoof IP packet of anybody else's. Okay, no source address authentication. Okay, destination address, anybody can use any destination address. Okay, all right. Now based on these two, lot of attacks are possible. So now this source address authentication doesn't happen in IP packet, doesn't happen in ICMP packet. Some features of ICMP packet, like we have seen, like ping or redirection, etc., can be exploited uh, to form an attack. All right. So we can do ICMP spoofing, we can do ICMP based attacks, and lot of you cannot do it by yourself. Suppose you want to DDoS attack, you cannot do it by it. So you'll have to buy the tools to do that. And all these tools for DDoS are available either in public domain, but more sophisticated are available in kind of in the dark net, right? So now you can buy, for example, millions of bots that will do DDoS attack on your behalf. All right. Okay. Any question? Are you able to understand what is being taught? I know it's very fast, but